Welcome, Michael here at the helm of the spaceship Exodus. I have discovered something amazing in Grasshopper 2, a way of sculpting and planning and modeling that I have been waiting for since the early 1990s, and that's the data visualization of calculus. So what I'm going to do is I'm going to look into beautiful curved objects by ancient artifacts, helmets, Venuses, combs, furnishings, fabric, anything I want. And I'll grab a basic mesh off of online, some sample to draw from. And what I'm doing is I'm using this basic identity that a function, whether that function is written as a function this way, or if it's written as a text, as a script, I'm going to basically use that to use the limit laws to discover these beautiful curves. So example being, as you can see as I go through here, I'm just choosing an arbitrary point to start right here. And you don't have to match the design of something, but because Rhino is based in curves and surfaces, you'll see how easy this is. So I've gone through and just started with a point in the middle. And that's basically, I was building a little axis to rotate things around or to mirror things if I so choose. Because I'm going to build this helmet in parts, but I'm going to use the curves that I'm generating and rebuilding to then inspire further designs. And so I'm going to stay with pretty basic designs, half modeling them. Right now I'm just worried about the cheek, but I want to show you like just going into this and considering the way I'm building curves from functions. This point is just a move vector, so there's not much to look at, but it basically gets us over here to the side arbitrarily. Like, where do I want to start positioning this? So I can see I have control over that, like incredible control and numerical control. So I'm going to model between very small numbers only because my functions may be relative to that. So you can really position these things. Now what I do then is I work on the curves, but I'm using multiplying functions. And you can see I'm playing with curves within the function editor until I'm happy with them. I'm not scripting them. I'm actually just pushing and pulling these points around in full detail until they function in a way. Now, the only thing I don't like about Grasshopper is I haven't found a way to output this data here. You can see it down here in the bottom. It's negative 0.5219, blah, 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 x cubed. I want a way to copy that so I don't have to look at it. But what I'm doing is looking at that data, driving that initial geometry because of that function, but then I'm scripting that function into a text. And what I'm going to end up doing is eliminating this and writing multiple cubed, squared, and single polynomials as functions that I can play with the coefficients. So I'm not just going to play with the coefficients of basic parabolas and hyperbolas and conics and all those wonderful things. I'm going to play with the coefficients that make these beautiful curves that come from looking at a lot of Spartan helmets. So in that, I can start to change the length of these things. You can just see the power of this. I mean, like if I go in here and start playing at one, and this is just the range of what I want to do with that. You see how you can start to have control over that. But if I go in here and have that precision modeling on each one of these multi-dimensional polynomials, I'm going to have incredible control. The only step to do after this, because it's incredibly tedious and it's in your head, but it's fairly repetitive. But that means if it's repetitive and tedious, I should have any form come to it with these oriented points that directly inputs from those data or forms and generates these functions. So you can look at them, but I like the fine tuning. Don't ask me why. I mean, I could try and draw the curves and follow them and copy them from the meshes, but I'd rather generate my own kind of helmet that's specific to those. So this one's driven by the same thing, a multidimensional polynomial, and I'm using C Sharp, not Python, but C Sharp scripting, math function, the power of x to 3, the power of x to 2, and the power of x. Now, there are some coefficients on these that sometimes don't have, like they're brought down without an x factor, but they still move and position things. So as I go through here, I will fine tune these. I'm going to make these scripts harder and harder, but it's nice because I have this really nice control over these forms. And all I'm doing in the end, after I get close to these geometries, then I transfer them into a script that I can start to control, not to become dependent on the function editor, because it does have a tendency to crash. I can make them as complex as I want. I can go in here, and if I chose to script this as a node here, then I could have the specific thing written in, but I'm finding it's crashing in this thing. So two things I'd like Grasshopper 2 to have is fix that kind of function editor to have functions dependent on functions, which would be great. And the other thing is to make this output reachable. If you bring this output to a panel tool, it just generates another graph, which is kind of a pain in the butt. What's that going to tell me? It just shows me another graph of what I just graphed. And depending on the size and scale and the range and domain of that, whether it shows up or not. But you can see like this one, it's like a really nice little finesse when you get the basic points of what you want to drive this. And I've really just been kind of awkward and clumsy with it in the end, just to pull it out. I like that one because you get this curve, is after I'm done generating all those curves and those points, I'm putting them in as the four edges that will drive this surface. And I find just throwing them through this anvil rebuild curve is enough. So really nice little thing. It wouldn't take much to, I'll just do this for a second. One second. Pretty basic stuff. Mirror. I think we just mirror that one and a mirror over to the other side. There you go. So you got really nice, let's go into here and put that one over to a blue. And we'll put this one over to a yellow, an orange. And there we go. We've got a nice little form. Now I think there's a few things here. The blue and the yellow. There you go. You've got your helmet that's really starting to take shape. You've got nice finesse. I probably won't do anything beyond surface. I'll probably take those baked surfaces then into Rhino and start to thicken it. But right now, having full control over this helmet, generating some powerful scripts that I will then eliminate these functions and make these much more parametric. But you're getting so close to the precise. One thing I find with Grasshopper 2 is there's no need to reparameterize. Just work in your model between 0 and 1 or close to 0, and then use the basic number slider that's coming out. And I think that's why the basic number slider comes out and it's just a 0 to 1, and you don't have this kind of fast way of doing other things. So I hope I didn't eliminate anything. I just did. Let me go back. Oh, what did I do? There it is. There it is, back there. So without crashing it out or doing anything, I'm going to save that file. That is on my Patreon, the entire file. It's under the day 32, playing with Grasshopper 2. And I hope people find this very exciting as me. And when I start, I feel like a really dumb artificial intelligent thing trying to program these things. But I want the control and I want the freedom to not depend on these other forms. And there's enough free meshes to get you going online, but you might want to be working in precise, perfect mathematical equations instead of meshes to drive your form if you're a purist. And I just think pure math is where it's at. So let's see where it goes. Michael Wickerson at Wickerson Studios at the helm of the spaceship Exodus. All right.